Hello children, welcome back to Learn with the Physics Bro. See, in this video we will be discussing most important questions for NEET from the topic circular motion. See, these questions are very important and you cannot ignore. Okay, so let's go to the questions first in uniform circular motion. See, uniform circular motion means body moving in a circle with a constant speed. Even though the speed is constant, velocity is variable because the velocity at any point on the circle will be directed along the tangent to the circle at that point. So as the direction of the velocity is continuously changing, velocity is variable, only the speed will be constant. So both velocity and acceleration are constant. Definitely velocity is variable, acceleration also a variable here, because see, in uniform circular motion the only acceleration experienced by the body is the centripetal acceleration or radial acceleration. See, and it is always directed towards the center. See, its magnitude is v square over r. When the body reaches diametrically opposite, see here also the acceleration is directed towards the center. Okay, the magnitude is again v square divided by r. So even though the acceleration has a constant magnitude, its direction is continuously changing. Velocity has a magnitude, its direction also changes throughout the motion. So both velocity and acceleration are variables. Okay, both velocity and acceleration are variables. So this must be the correct option. Okay, now speed and acceleration are constant. Speed is constant. Magnitude of acceleration is also constant, but we cannot say that acceleration is constant. Okay, but velocity is variable, that's wrong. Okay, velocity is variable, that is correct, but acceleration is not constant. Okay, so this statement is wrong. Option C. So the only correct option is B. Now let's see what we have next. See, the ratio of the angular speed of the minute hand and hour hand of a watch is. What's the expression for angular speed? Angular speed omega, this is equal to 2 pi over capital T, where T is the period. What is the period of minute hands? See, minute hand takes 1 hour for one complete rotation. Okay, so the period of minute hand is 1 hour. And what is the period of hour hands? Hour hand takes 12 hours for one complete rotation. So the period of hour hands is 12 hours. So we have to find the ratio of the angular velocities of the minute hand and hour hands. See, when we find the angular velocity of minute hands or the hour hands, see, this 2 pi will be the same in both cases. So that 2 pi is a constant. So this equal to and constant, then we can say omega directly proportional to 1 by t. 1 by t means angular velocity is inversely proportional to time period. Okay, now here we have to find the ratio of two angular velocities, omega 1 divided by omega 2. See, as the angular velocity is inversely proportional to periods, omega 1 by omega 2 will be t2 by t1. T2 by t1. Okay, t2 divided by t1. See, if it had been directly proportional, then omega, see, if it had been omega proportional to t instead of 1 by t, then omega 1 by omega 2 will be t1 by t2 if the proportionality is direct. Okay, if it is inversely proportional, then omega 1 by omega 2 will be t2 by t1. See, the second case is hour hand, that takes 12 hours. And the first case is minute hand, that takes 1 hour. So the ratio must be 12:1. Okay, this one. Now let's see what we have next. Okay, see, a particle is moving in a circle with uniform speed, it has constants. See, when it moves in a circle, velocity at any point will be directed along the tangents. So velocity is not constant, but its speed is constant. If the velocity is variable, okay, then linear momentum, being the product of mass and velocity, also must be a variable. So velocity is not constant, linear momentum is not constant. Acceleration in uniform circular motion is radial acceleration or centripetal acceleration, and it is always directed towards the center. Okay, so when the body is here, the acceleration will be towards the centers and it is v square by r. When it is here, acceleration is again towards the center and it is v square by r. So even though the magnitude of acceleration is constant, direction is continuously changing. So acceleration is also not constant. But the kinetic energy, it's a scalar. Body is moving with a constant speed. So half mv square, that is the kinetic energy. It will be constant. Okay, so this must be the correct option. Now, see, a can filled with water is rotated in a vertical circle of radius 4 meter and the water just does not fall. The period of rotation is. Children, see, consider the case when the bucket is at the highest position of the vertical circle. See, right? This is the bucket, okay? When it is at the highest position, water should not spill, or let us say water must be at rest with respect to the bucket. Okay, water must be at rest with respect to the bucket. See, bucket is moving in a circular path. So, bucket experiences centripetal acceleration. Water must be at rest with respect to buckets, which is an accelerated frame of reference. When a body is being observed with respect to an accelerated frame of reference, we have to consider the pseudo force or inertial force. Here it is called centrifugal force, and it is it is directed away from the center of the circle, and it is mr omega square, where omega is the angular speed. Okay, and the second force acting on water is weight mg, that is acting vertically down. As the water is to be at rest with respect to the bucket, these two forces must balance each other. Okay, so let's say mg equals mr omega square, okay, mr omega square. Okay, this omega square you can write 2 pi divided by capital T, that is omega. Okay, then omega square, right, omega square. Now see, here we have m, and this m can be cancelled. Okay, in here in the denominator we will have t square, that you can take to the left, so it becomes t square. Okay, this is equal to, on the right side we have 2 pi whole square, means it is 4 pi square. Okay, then r. Okay, and this g can be taken to the right side, then comes in the denominator. Now this pi square and g are nearly equal, so they can be cancelled. The value of radius is given as 4 meter. So on the right side we have 4 into 4, or 4 square. So t square equal to 4 square, or t, time period, is equal to 4 seconds. So this must be the correct option. Now let's see what we have next. Two particles of equal masses are moving in circular paths of radii A and B with the same period. The ratio of their centripetal forces. Children, what is the expression for centripetal force? See, you must be knowing centripetal force is mv square divided by r. This is the popular expression for the centripetal force. But we have one more expression for the centripetal force, that is F equal to m omega square r. What is that omega? It is the angular velocity. Omega equal to angular velocity, and it is 2 pi divided by capital T. Here we have got two bodies, and two bodies are moving in circles of radii A and B with the same periods. See, the time period is same for both the bodies. So, angular velocity omega equals 2 pi divided by capital T. 2 pi is constant for all. Here we have two bodies, and both the bodies are moving with the same period. So, T is same for both the bodies. So, omega is same for both the bodies. Now, the question is, which expression we have to consider in to solve this question. Any expression you can consider, but here the question will be simple, or it will be easy to solve when you consider the second expression. We have got two bodies moving in circular paths. Both the bodies are of the same mass, and they are moving with the same angular velocity. So m is same for both the bodies. Omega is also same. So m omega square does not change as we move from one body to the second body. For both the bodies, this product m omega square is same. So that's a constant. This constant and equal to, that combination we can replace by proportional to. Usually we do the reverse process. Okay, if f is proportional to r, we can replace this proportionality by an equal to, see, after multiplying with a constant of proportionality. So the same thing we can do in the reverse order also. Okay, see, so f that is directly proportional to r. So we have to find the ratio of the centripetal forces for the two bodies. So let's see, F1 divided by F2. As here it is directly proportional, this ratio must be R1 over R2. But here the radii are given not as R1 and R2, but A and B. So this is A over B. So this must be the correct option, A by B. Okay. Now let's see what we have next. See, a particle of mass m is executing uniform circular motion on a path of radius r. If p is the magnitude of linear momentum, the radial force acting on the particle. Radial force means the centripetal force. Okay, here also, see, linear momentum mv, this is equal to p. See, what is centripetal force? It is mv square by r. So we have to make mv square by r. Here we have only mv. So square both sides. So m square v square. This is equal to p square. Okay. Now you can divide both sides, or see, here it is mv square. mv square. Take one m. See, from this m square you can take one m to the right side. So you will get p square divided by m. P square by m. Okay, so when you take 1 m out of this m square to the right side, see what remains on the left side, that will be mv square. And on the right side, you will get p square by m. See, the expression for centripetal force is mv square by r. Here we have mv square. So divide this by r. Okay, if you divide left side by r, you have to divide right side also by the same factor r. So r. Now this is, see, the expression on the left side is centripetal force. So this is equal to p square over rm. Okay, so here we have p square over rm. Now let's see what we have next. See, keeping the banking angle same, to increase the maximum speed with which a vehicle can travel along a curved road by 10%, the radius of curvature of the road has to change from 20 meter to. See, what is the maximum speed with which a vehicle can take a turn of radius of curvature capital R and banking angle theta? See, it is V equal to root of Rg tan theta. V is the maximum speed with which the vehicle can take a turn of radius R when it's banged at an angle theta. Okay, now see, if you square both sides, you will get, this r, radius r equal to, what do you get? V square divided by g tan theta. V square by g tan theta. Children, here g is constant. Tan theta is also constant. So 1 by g tan theta is constant. So you can say r directly proportional to v square. R directly proportional to v square. Directly proportional. Okay. Now see, then the final radius is r dash and the original radius is r. So this will be equal to, okay, v dash divided by v whole square. V dash by v whole square. R dash by r equals v dash by v whole square. Now see, original radius is 100%, that is 1r. 200% radius means it is 2r. 150% means 1.5r. Always original is 100%. See, 120% radius means 1.2r. 80% of radius means it is 0.8r. 80% corresponds to 0.8r. So in order to convert percentage to fraction, you have to divide by 100. In order to convert, fraction to percentage, you have to multiply with hundreds. Okay. see, originally the speed was 100% and it is 1v. Now the speed is to be increased by 10%. Means the speed originally 100, it is to be increased by 10%, means it becomes 110%. 100% is 1v. 110% will be 1.1v. Okay, so v dash we can say v dash equal to 1.1v. 1.1v. Right. Now see, if v dash equal to 1.1v, now see, r dash divided by r equals v dash divided by v. See, if when you put v dash equal to 1.1 v divided by v, that you will get 1.1 square. And see, what is the square of 11? 121. So the square of 1.1 will be, this is 1.21. 1.21. So r dash, final radius, this is equal to 1.21 r. That r is given as, see, 20 meter. So when you put r equal to 20 here, see, this will be 1.21, okay, into 20, or let us say 12.1 into 2. 12.1 into 2 means 24.2. So the final radius is to be 24.2 meter. Okay. Now let's see what we have next. See, a body of mass m is moving in a horizontal circle of radius with uniform speed v. Means uniform circular motion. Velocity is varying continuously, but the magnitude of velocity or the speed is constant. Kinetic energy is constant. Okay, being velocity a variable, linear momentum also will be variable. Okay, acceleration is also variable. Okay, so what is the question? When it moves from one point to a diametrically opposite point. Okay, see, when it moves from one point to a diametrically opposite point, here, see, this is the velocity, and see, diametrically opposite point, see, this is the velocity. Okay, and this is directed downwards. Let me take it negative. So this must be directed upward and it is positive. Okay, so here the momentum is m into minus v or minus mv, and here the momentum will be m into v plus mv. So as the body moves from one point to a diametrically opposite point, even though the magnitude of linear momentum does not change, direction gets reversed. Okay, here it is downwards while here it is upwards. Okay, so linear momentum does not change. That is a wrong statement. How do you find the change in linear momentum? See, in physics, change means always final minus initial. So this is the final linear momentum, this velocity multiplied by mass. So it is mv. And initial linear momentum is minus mv. So mv minus mv, that will be 2mv. Okay, so the linear momentum changes by 2mv means that's a true statement. And here we have kinetic energy changes by mv square by 2. Kinetic energy remains constant throughout the motion because the speed does not change. Okay, so the kinetic energy changes by mv square by 2 means it's a wrong statement, or kinetic energy changes by mv square by 4, that's also wrong because kinetic energy remains constant throughout the motion. Okay, now see what's next. Wheel initially at rest is subjected to a constant angular acceleration about its axis. It rotates through an angle theta 1 in the first 2 seconds and theta 2 in the next 2 seconds. The ratio theta 1 by theta 2. See, there are many equations in linear dynamics. Okay, for example, v equals u plus at, s equals ut plus half at square, v square equal to u square plus 2as. See, we have corresponding equations in rotational motion also. Corresponding to, corresponding to v equal to u plus at. Corresponding to v equal to u plus at. In linear, this is equation in linear mechanics. Corresponding equation in rotational mechanics is omega equals omega 0 plus alpha t. Here a is linear acceleration and here alpha is angular acceleration. U is initial linear velocity, omega 0 is initial angular velocity. V is final linear velocity and this is final angular velocity. Okay, and see here S is equal to ut plus half a t square. Okay, corresponding equation in rotational motion is theta equals omega 0 t plus half, okay, alpha t square. Okay, half alpha t square. Children, see, in linear mechanics we have studied when a body starts from rest and moves with a constant acceleration. When a body starts from rest and moves with a constant acceleration, see here velocity is 0. And if it moves with a constant acceleration, its velocity changes equally in equal intervals of time. Okay, so after a time t, its velocity becomes v. After another equal interval t, its velocity will change by the same amount. Then only we can say that it's moving with a constant acceleration. So velocity increases by same amount. Okay, so velocity becomes 2v. Okay, after another time interval t, velocity becomes 3v. See, here if the displacement, here it is s, then here it will be 3s. In the next interval it will be 5s. Next interval 7s. Means when a body starts from rest and moves with a constant acceleration, ratio of displacements in successive equal intervals of time 1:3:5, like that. Okay, and see, same thing we can apply in rotational motion also, or angular motion also. See, instead of linear displacement we will have angular displacement. Instead of initial linear velocity, we will have initial angular velocity. Okay, see, corresponding to this linear acceleration, we will have angular acceleration. See, in this case, body must be starting from rest and moving with a constant angular acceleration. Then the ratio of displacements in ratio of angular displacements in successive equal intervals of time. See, during the first interval, suppose the angular displacement is theta. During the second equal interval, angular displacement will be 3 theta. If we consider a third interval of the same duration, then theta 3, during the third interval, it will be 5 theta. Okay, in the next interval of the same duration, displacement will be 7 theta, like that. Okay, here we have to find theta 2 over theta 1. So it must be 3. Okay, 3. Right. Now let's see what we have next. A body slides down a frictionless inclined plane which ends in a circular loop of diameter capital D. Then the minimum height from which the body should be released so that it may just complete the loop is. See, in vertical circular motion. Okay, suppose a body is hung from a rigid support by means of a string. Suppose some velocity is given to the body at the lowest point. See, it will go like this and return after some time. If the velocity that's given at the lowest point is increased, okay, it will go some more and then returns. So there is a minimum velocity that must be given to the body at the lowest point so as to just complete the vertical circle. And it is root of 5gr. If the velocity given to the body at the lowest point is less than this, it cannot complete the vertical circle. It will return along the same path. But if the velocity given to the body at the lowest point is greater than or equal to this, it will complete the vertical circle. Okay, if the velocity given at the lowest point is root 5gr, then the velocity when it reaches this position will be root 3gr. And the velocity at the highest point, that will be root gr. Okay, here it will be root gr. Okay, if the velocity given at the lowest point is root 5gr. If the velocity is more than root 5gr at this point, then the velocity here will be more than root 3gr. And here it will be more than root gr. Anyway, in order to complete a vertical circle, the minimum required velocity at the lowest point is root 5gr, where r is the radius of the circle. Now see, we have released a body. Okay, released a body from here. Okay, this is a frictionless path. A body is released from here. And suppose that body is released from a height h. Okay, see this height from the ground. Okay, this is capital H. Okay, it comes like this and see completes a vertical loop. So the velocity here it should be more than root 5 gr. And then what should be the kinetic energy at the lowest point? Minimum required kinetic energy is half mv square. So half, okay, mass m, velocity square, velocity is root 5 gr. So its square will be 5 gr. Next is radius. But that radius we can represent it as half of the diameter. D is the diameter. So radius will be d by 2. This is half mv square. The kinetic energy at the lowest point. That must be equal to potential energy at the highest point. That potential energy is mgh. So this is equal to mg capital H. Okay, here we have m. This m and this m can be cancelled. This g and this g can be cancelled. Okay, so on left side we have 5d over 4. Okay, 5d divided by 4. This is equal to capital H. So the minimum height from where the body should be released is 5d by 4. Okay, children, these are very important questions. So all of you should learn all these questions carefully. Thank you.